Paige, I've got 3 minutes after 2. Should we go ahead and get started?
Sure. Let's do it. Kick it off.
All right. Welcome, everybody, and thank you for joining us for the premiere of the Forest Products Society new monthly webinar series, the Forest Products Insights. Each month, this series will welcome a new guest speaker sharing their research, technical expertise with a live audience. We'll be joined by our host, Paige Edelstein, and learning more about the forest products industries and the ever-changing knowledge behind it. The series will take place on the third Wednesday of each month and will be an open conversation where your questions can be answered and ideas shared amongst your peers within the forest products sector. If you're not an FPS member, we also invite you to learn more about Forest Products Society and consider a membership in our organization. So thank you again for joining with us today. We look forward to engaging conversation, and thank you for your support of FPS. So without further delay, I'm going to turn it over to today's host, Paige Edelstein, FPS's immediate past chairperson, who is hosting today from Boise Cascade in Oregon. So Paige, stage is yours.
All right. So like Chris said, thanks for joining us. This is our first kickoff of our webcast series. Just to give you a little bit of an overview for the logistics of today's session. I'll introduce our speaker, Osei, in a minute, give you a little bit of background about him. And then we'll have 5 to 10 minutes where Osei will talk about his research, and then we'll open it up for questions and interactive discussion from you all. You've got the chat function. If you open up, there should be an option to open your chat box. Feel free to type in a question there to the group, or you can send it to me directly. I've got mine open so we can see if you raise a hand if you've got a question that way as well. But we would like to make this as interactive as possible. So please don't be shy and ask Osei what questions you've got about his research. So with that, I'd like to introduce Osei. If you remember, he was our 2020 FPS Wood Award winner. So that was announced back June. We had our virtual conference in June, and he was presented with his award then. Osei is a postdoc fellow at the Forest Products Development Center at Auburn University. He's actually a recent PhD. He just graduated in sustainable biomaterials, and he has a Master's of Science in Polymer and Fiber Engineering from Auburn as well. He also holds a Master's of Philosophy in Wood Science and Technology and a Bachelor's in Natural Resource Management from the University of Science and Technology in Ghana. His research has focused on sustainable development of bio-based adhesives and wood composites. He is currently researching the expedited wood drying with supercritical carbon dioxide and developing sustainable bio-based self-curing adhesives with broader applications in wood composites manufacturing. So we've got a wealth of knowledge with our first speaker here from Osei. So with that, I will kick it off to you, Osei. And like I said, keep your questions towards the end, and we'll have our interactive section, or you can just type it in the chat box. So the floor is yours.
Thank you, Paige, for the introduction. I'm excited to meet all of you once again. The pandemic has kept us a little bit distant from each other, but thanks to the organization that has brought us so close together again. Today, I'll be going through some portions of the work that we have done so far during my PhD program. So today we are going to go through the production of oriented strand board utilizing bio-oil and epoxy resin. A little bit background about Osei. So Osei was born in Ghana, which is in the western part of Africa. So when you look at the map that is shown here, you would see that this is the map of Ghana. And at the heart of Ghana is where Osei grew up as a teenager. And going through the map, I saw that, okay, Ghana's size looks a little bit small on the African map, but it is almost the size of Alabama and Georgia combined. It is about 35,000 square kilometers shy. That is how the size of Ghana is. But growing up, I had a chance to see, if you could see the truck that is loaded with different kind of timber. That was what I used to see growing up. Like, it will ply the road. So in my mind, I was asking questions like, okay, are trees being planted to replace them? Are they being utilized efficiently? Then, luckily, when I got to the university, so one of the areas leading to where I schooled, they have moved them from that area. It was used to call Angloga, where they process wood, but then the pile of dust that you see were some of the conditions back in 2004, thereabout. But then successive governments are trying to work hard to contain that. And then they are bringing in some of these things that you see. So my question still has been that, are these waste going waste, or are we trying to find a better solutions for them? But whilst I was thinking about this in 2004 and 5, the US Department of Energy had also thought about something similar. So they were thinking about utilizing the entire wood biomass from its crown to its root, such a way that they could replace almost about 18% of the US chemical commodity. So joining our lab in 2017 here in Auburn, I was super excited. And some of the motivation that was running through my mind was that society was, the population of people keep on growing, and then demand of certain commodities will inevitably grow. So, and that trickles down to the environmental discussions that have been going on over the years, talking about petroleum-based resources, which have been known to be very limited, unlike wood, which we can sustainably use. So the overall motivation for our research when I started was that it has a government support. Two, the demand for bio-based products are going up, and we can see from our current daily intercourse with people, showing that indeed society is levitating towards that direction. So when we talk about bio oil, it is essentially a liquefied form of biomass in general. And this could be achieved in several other ways. It's actually a thermochemical conversion method. And presently, I can say with much delight that pyrolysis is being commercialized, especially in Europe, as a heating oil. And then we have hydrothermal liquefaction. I did the two, but what I'm going to share with you is the fast pyrolysis method. So during the production of bio-oil, what actually happens is that either you use a wood waste or wood that is mostly not really valuable in terms of its utilization, or you could still use good wood chips, and then you feed it to the auger reactor. There are other pyrolysis reactors that you could use, but this is the benchtop one that we used in the production of the bio-oil that we use. So it goes through the feeder, and then there are several other screws that extrudes it through the pipes, and then it is being heated, and the gases that comes out are being condensed in these condensers, and then they are collected in a form of bio-oil. I must say that they contain significant amount of water anyway, around 20 to 30%. And they are produced essentially without oxygen at high temperatures. So when we had the bio-oil, we wanted to find out whether it would be good as a chemical feedstock. So we ran some analysis on it, and we realized that it had It contains some substantial amount of phenolics coming from the wood biomass biopolymers, especially the lignins, cellulose, or the hemicelluloses that are in wood. We also ran phosphorus NMR analysis on it to quantify the amount of hydroxyls that are in the bio-oil. And this we did in the backdrop of our minds that we wanted to have an alternative adhesive that had not been used traditionally in the wood composite industry, but has a huge potential. So we had the mindset of using epoxy. We had previously epoxidized the bio-oil to produce a bio-oil-based epoxidized adhesive, but what I'm going to share with you is just the physical blend of the bio-oil. So this is very critical in the mixing ratio because it affects the amount and proportion of bio-oil to epoxy to use. So we went to the production of the bio-oil-based epoxy. And then we came up with a summarized kind of reaction that was actually happening in the system. So we use FTIR to ascertain some of the claims that we made that the bio-oil is compatible with epoxy resins and will be able to form a complete cross-linked polymer. And we're able to realize that, especially when you look at the FTIR spectra, you would see that the neat or unmodified bio-oil that we have here, the spectra, and then the liquid form of epoxy resin. When you look at the spectral bands, you would see that this is the epoxide ring. And when you go through the various levels of bio-oil substitution, you realize that that actually is completely removed from the spectra. We also did some SEM analysis to find out the impact of the bio-oil. So we know that epoxy resins, one of the main reasons why it has not been used in the wood composite industry is that it is brittle and then it's expensive. So we anticipated that using bio-oil should, one, reduce the cost and then also improve some of the dimensional properties of the OSB boards and also improve the brittleness. And we could see clearly from this SEM analysis that the bio-oil actually reduces or improves the brittleness. As you could see that the surfaces of this one is very smooth, and then this one shows a much diverse morphology. So in the lab, we're able to mimic some of the work that is being done in the industry. So we're able to produce boards with our resin, that's the epoxy resin, that is based on bio-oil. And we went through some of the characterizations that we did. And we're excited to find that the epoxy resin itself works most of the time, especially in its dry state, but then during the wet state, it degrades. But adding bio-oil, one, did not affect the strength properties, and also at lower substitution levels, it improved the properties. And then it is almost or similar in terms of strength properties to MDI, which is currently being used in the industry. A similar story could be said about the internal bond strength and then the thickness well and water absorption. So by this indication, we have a provisional patent on this. I could not share some of the details of some of the blending mechanism and then the epoxidation mechanism. But what we could share is that indeed it is a promising route to having an alternative form of adhesive that is not entirely based on petroleum resources. On this note, I would like to thank some of our sponsors and then our collaborators. And thank you all for having the time to listen to this introductory webcast. And then if you have any questions, I'll be excited to explore with you. Thank you.
Awesome. Thanks, Osei. That was a great overview. I've got a couple questions, but I'd like to open it up for the group first. You can either unmute yourself and go ahead and ask your question. If you feel more comfortable raising your hand or typing it in the chat box, that works as well. Okay, we've got one from Tom Miles, and he wrote in the chat, can the bio oil be made by slow pyrolysis?
Yes, I think that I did not mention that aspect. It could be made that way, but then in slow pyrolysis, you tend to have a much reduced bio oil yield from my knowledge that I've acquired in that. Yes, you can, but then the bio oil yield is significantly affected.
So not as, you don't recover as much. Is it also less efficient for the actual process? I would assume your higher temperatures with the fast pyrolysis would make it more efficient of a overall process?
Yeah. Okay, I was going to add something, but then I think if maybe somebody may have that question or something. All right, so I wanted to add that this is a promising route, especially in the wood composite industry. And then in an integrated mill, you would normally have the mills burning the either the sawdust or the wood chips directly. If you go through the bio-oil pyrolysis route, one, you have a heating oil. Two, you have the char that comes out. And that char now is a hot commodity because it is used mostly in soil remediation. And then currently we are also working on it in our lab to be used as a filter in the textile industry and also as an activated carbon. So instead of just burning it directly, having a low calorific value, you would go through this route, have a chemical, have a heating oil, and then have a commodity that you can make extra profit from it. So that is the prospect that we are looking at in the bio oil.
Okay, and that was going to be part of my question around the commercialization. So you mentioned that there's some companies or some facilities in Europe that are using this commercially, or is there any in North America that you know of or that you've been able to visit?
Okay, so those ones that I have seen here, they are not really, they are just on pilot basis, but the other ones that are huge and they do huge commercialization, they are mostly based in Europe. I think I can share, if anybody wants, I can share about 2 or 3 articles that list all the current commercial pyrolysis manufacturing plants.
Yeah, I think that's interesting. And you make the comment about the expense of the epoxy. I'm not expecting to know the exact expense of the bio oil process, but I would be curious, how that weights. So you've got the increased, you're less brittle, you're less expensive, but how does that offset when you add the expensive epoxy? Are you still ahead of the game cost-wise to some of the traditional like MDI adhesives? Do you know where that falls?
Yeah, okay, sincerely, I cannot really comment about such a cost break-even, but one thing I know for sure is that at the current production rate of pyrolysis bio-oil, it is about twice less expensive than the cost of epoxy or
Okay.
that is per pound, and then that of MDI. So doing that kind of substitution should be able to offset the price.
Yeah. Yeah. Okay. Ooh, that's good. We've got two questions in the chat. One from Joseph. He says, I don't have any personal experience, but I have heard that bio oil can smell bad. Is that smell an issue in using bio oil for wood adhesives?
Okay, bio oil has a very pungent smell, and then not that is super bad. If you like barbecue, you may like it because that is the main thing that they use. That is pyrolysis bio oil that has gone through
Kind of
some
smoky smell.
smoky acrid smell. But then the good thing is that the smell significantly reduces. It doesn't go away, but significantly reduces when it becomes a cross-linked polymer. So you would not have that pungent smell in your OSB panel as you would see for the bio oil itself. Yeah, but there are now technologies to remove the smell from the bio oil. So this is just an ongoing research. So we hope that such processes will not adversely affect the bio oil properties, but still maintains it and will be able to use it in the resin formulation.
Yeah, that's a good question, and kind of an interesting. You come up with the technology, and then you've got to integrate in, how the end use is going to react or want out of the product. So that's good. There's some solutions that maybe will be looked at. Okay, Chris Hunt has a question. Have you been able to do MOE/extensibility/MOR on the bio oil epoxies?
Okay, so I have actually done some DMA on the epoxies, the bio oil epoxies themselves, but I have not done the extensibility test on those bio oil epoxy resins. But for the MOE and MOR, that has been done using DMA.
Okay. I don't know, Chris, if you want to unmute and if you have a follow-up question to that, or if that's good.
I was just wondering, extensibility, being able to, well, I'm looking at brittleness basically. Do you have any analytical data that points to the brittleness of your bio oil epoxies in comparison to the standard epoxies?
Yes, I could share that later, but I have that data there.
Can you give us just a broad strokes general general impression of where it's going?
So what the bio oil actually does is that it actually improves its ductility. So that but then the truth is that you cannot really predict that in the your OSB metrics because you have another factor coming into being, that is the wood strands. So even with the epoxies themselves, when it comes into the wood metrics, then at the end of the day, whatever explanation I'm giving does not really count.
I'm glad you're being careful about that.
Yeah.
Okay, good. Thanks.
All right, good. Great question, Chris. So other Chris says, what is the consumer/end user impact? So you've got a better product, less expensive, less environmental impact. How does that tie in with the end user?
So at the end of the day, the end user would have an environmentally sort of safe product that they can also talk about having to use like a product that they can say that is produced sustainably. But then there is another aspect of this whole thing that is how expensive is that product going to be. But then, as I've said, the the producers are going to benefit, but I don't know how in the long run is going to change the pricing for these commodities that we sell. I have not done any analysis on that yet.
Okay. Yeah, and this kind of leads into a question that I have. Have you looked at any other product applications outside of OSB where you could use this this type of bio-oil epoxy?
Yeah, okay. We have also tried this in particle boards, which also works fine. And then as well, we have also looked at using this one as that's the epoxy bio-oil as a surface coating. Because we believe that the bio-oil itself in some time past have been used as a protection against insects. So we wanted to find out if we use that one as a coating, which is also ongoing.
Yeah, that's an interesting application. Okay. Cool. Okay, we've got another question in the chat from Maria. Hi, Maria. I was wondering if you have measured surface free energy of the bio-oil and then compared that with other resins.
No, Celeste, I have not done the surface free energy. And the reason is that we were actually proposing a series of theories about the bio-oil epoxy, which I was not able to get the chance to divest into that. So that has been a recommendation for the next student that is going to take up that research.
Okay. Good. Okay, we've got another one in the chat. This is great. Thank you all for your questions. From Tom, he asked, would the producer be able to recover financial credits for carbon dioxide removal by making the bio-oil? And are there reference standards or specifications for the oils to ensure consistent quality? That's a great question.
Okay, so for the question about recovery of financial credits for carbon dioxide removal, I would say yes, because I reviewed one paper from one of the commercial producers, BGT. I've forgotten the entire name, from Netherlands. I think they alluded to that fact. So I can still have that and then perhaps maybe share that one later. So yes, you have that option as well of recovering any financial benefits or credits from the production of bio-oil.
Okay, and then what about any standards or specifications that should be met on the quality side? Is there anything in place for that?
No, not currently, no. Not that I know of. It may be, but I'm not sure.
Okay. And is the, do you think, why is the reason that most of these commercial facilities are in Europe? Is it just the technology was kicked off there, or is there another reason? What do you think?
Okay, so I know that that facility at least has been there since for some time now. I know that it is always difficult in most of the North American countries, North American plants, to adapt to these changes, all because of cost. You see, the prices of petroleum keeps on up and down fluctuating that way. So I think the incentives to actually go into it has not been that much, although the Department of Energy is in full support of that. So I'm just looking forward to the near future that everybody will just come on board, and then it will be a thing of the past where North America will be able to produce its own bio, because we have the potential anyway.
Yeah, no, and I think that's a good comment. A lot of times with some of the newer technologies, the green technologies, if you want to call them, having that incentive to get it kicked off and to to provide sort of an investment opportunity is sometimes the best route to get it going. And you're doing all of the background technology side to make sure we're there. So that's good. Okay, we've got another question from Daryl. Do you envision production of the bio oil at the OSB mill, or would this be something where there would be a producer's mill and then shipped over to the OSB facility to be used in layup?
That is a good question, Deli. In my estimation, so the main motivation and my excitement was that I was looking at integrated mills. So those facilities that are visited around Alabama and then in Georgia, some of them are huge. So they should be able to produce these things themselves. And then especially OSB manufacturing plants. So in my estimation, almost every OSB plant that is big enough should have these simple facilities on board to be able to produce this. In the near future, there will be other people who would say, okay, don't go through all this stress, we are going to produce it for you. But then I'm also looking at the advantages that you may get from the biochar and then the other component of the bio oil as well. So let's see what happens in the near future. I know that this will be something that in the years to come should be materialized.
Yeah, and that's a good question. How will you integrate it in with the current process? And maybe you could speak a little, Osei, to the type of technical knowledge that a facility or a company would need to have this integrated in with their process. So like I'm thinking for Boise Cascade, we are primarily veneer-based LVL I-joist producer plywood. So we're the manufacturer side, and then we have our adhesive suppliers that we work closely with, but we don't necessarily have the internal specialist on the adhesive side. We rely on our suppliers to provide that. And I'm wondering, how that would be a potential if you had an OSB mill producing it. Would you have maybe a technologist that would be, assigned to the bio-based epoxy or bio-oil epoxy side of it?
Yeah. Okay, so that is a good question. And then what I'm thinking is that let's say, for example, if Boise Cascade obtains most of its adhesives from manufacturer A, and then manufacturer A decides to produce, let's say, for example, the epoxy, BioCascade has the capacity now to produce their own bio oil so that they could have their own mixing or blending facility to use. That is something that I think could be done other than getting it directly from, so that you get some sort of a cost savings in that process.
Right, and your expertise, you don't have to go hire a team of chemists to manage your epoxy side. You could. That's an interesting. That's a good idea.
Yeah, this technology does not require a huge chemistry. It's a little bit or relatively simple to adopt.
You're doing the hard chemistry part for us. You're getting all that background work done. Okay, good. We've got another question in the chat from Tom. What is the value of the oil as an epoxy additive, like a price per pound? Do you have any idea?
Tom, this question has been like a battle, but then I know currently that epoxy brands per pound is somehow between 1.9 cents to 2.5 cents per pound. And then the bio oil ranges around 7 to 9 cents per pound. Yeah. The exact figures are very difficult to estimate. There has been one publication recently that talks about these kind of values, but then it's still something that is very difficult. It's still at the infantile stage of production. So I'm still looking forward to seeing this kind of production in the near future.
Okay, good. And you mentioned a little earlier around the optimum raw material going in to produce the bio oil. What can you speak about that a little bit? Like what gives you the ideal product outcome? What would you put in?
Okay, so all that you need is your wood chips or wood fibers.
Is there a certain species that's best?
That is a huge question to ask.
Or,
Okay,
or maybe what did you use for your studies? Can you speak
yeah,
to
okay, so I have looked at using grass, and then I've also used southern yellow pine. There are other species that people have looked at, and then the yield is almost always the same. And then because the only changes will be perhaps the amount of hydroxyls based on the cellulose amount, and then the hemicellulose amount, and the lignin amount.
Mhm.
But then it's still in the same ballpark. So once it is a biomass that can be pyrolyzed, you should be able to obtain almost similar properties.
Okay. Okay, so yeah, that's a little, I mean, you can be flexible with what raw material you have to put in, but I mean, southern yellow pine, that's a popular, at least in the southeastern United States, so that's readily available.
Yeah,
You
and
don't need some.
the good thing about this technology is that you are no more going to sort of throw away the back of the wood. You collect everything, and then you can use it as well.
Mhm. Okay. Okay, good. And that kind of leads into the next question on the chat. How long does it take to produce the oil, and what's the yield efficiency?
Yes, so in terms of time, the residence time for the production itself is 1 to 2 seconds. But then the overall time will take you almost about 30 minutes. And the conversion rate currently per the fast pyrolysis is between 70 and then 50. But then they are now scale-ups that are looking at 80% bio-oil recovery. So that is what the current technology stands at.
Okay, and so let's just take the 80% scenario. So your other 20% is essentially waste, or what?
Yeah, so the 21 will be some of the gases that could not be compressed back to the system, and then the other one will be your biochar, which is not a waste. It's now an added value that you could use.
Yeah, oh, that's great. Yeah, sounds like there's a good market for that. So it would be lucrative.
Yes.
Okay, good. What other questions do folks have? We've got maybe 5 or 10 more minutes here. And like I said, feel free, either use the chat or you can take yourself off mute.
Yeah, this is Tom. I'll take myself off mute. I chair the U.S. Biochar Initiative. So the biochar is currently worth about 40 cents a pound.
Oh, okay. Please, you did not mention your name.
Yeah, Tom Miles.
Oh, okay.
So the one of the questions I have is the Midwest Research, the national, which runs the NREL, the National Renewable Energy Laboratory, did lots of work on wood-based oils as resins and adhesives in the 1990s.
Mm-hmm.
And one of the issues that Chris and others was the consistency of the quality of the oil was a problem. So is that something that you see as a potential problem from the pyrolysis oils?
Okay, so that those concerns are now being addressed, and then they normally comes from the oxygenated compounds in the bio oil. So what we normally do now is that we okay, so I don't want to give like details about like the process that we have that is pending the patent, but what we essentially do with this one to cater for the consistency of the bio oil is that you can use a solvent to just keep it, and then you can get the solvent out when it is ready for you to use. So that is one of the main challenges of the pyrolysis oil, because the viscosity tends to go up, especially when you store it for a long time. It repolymerizes, let me say that. But there are technologies now to get that consistency ongoing.
Thank you.
So Tom, when that research was being done, what was the main, did they find what the variable was that made it less consistent in the quality? Was it incoming raw material? Was it the process, storage?
You have to ask Chris Hunt, who just left. Chris was the one that told me years ago that that was kind of one of the main concerns.
Okay.
But there were literally millions of dollars spent on developing pyrolysis oils for adhesives at NREL. You know, I can direct you to some of that research, but I never quite understood why it didn't go into use. And Chris's assessment was variability in the quality of the oil.
Okay. No, that's a great question. And Osei, it sounds like you've thought about that and you've got some solutions. So that's good. Thanks for your question, Tom. Anybody else? Got a couple more minutes.
Okay, so can I ask a question?
Oh yeah,
related to Tom?
ask the audience. Put it on them.
Yeah, so Tom, I'm interested in now the current technology that you have for the biochar. What is the main thing that people are using now? Is it for the soil remediation, or they are using it as an activated charcoal?
The current markets are primarily for either as a soil amendment or for filtration for environmental uses. And in filtration for capturing heavy metals, copper, zinc, cadmium that comes from the brake linings in cars and gets into stormwater. So stormwater filtration, green infrastructure, rebuilding urban soils, those have higher values than agricultural uses do. And it's not likely that what we found is that instead of being a substitute for activated carbon, biochar has its own values and is creating its own markets. And in terms of processes, most of the biochar today is made actually through combustion processes or gasification. And the combustion chars are high carbon fly ash, or what's called sometimes reinjection ash, which is the fine ash that you can recover in a multi-clone or cyclone in a power plant, in a biomass boiler. And so the salts carry on to the fine particulate collection, the electrostatic precipitator or baghouse, whereas the high carbon, sometimes up to 80% carbon, is what you reburn in the boiler, and if you can separate that and use it and sell it as biochar. The other major source is actually char that is a co-product of the gasifiers that are now used to provide heat for drying southern pine. So companies like KDS Systems and Hearst and so on make these staged gasifiers for gasifying wet sawdust to generate heat for their dry kilns, because it's cheaper than building a boiler under today's maximum achievable control technology regulations. So you spend $2 million on a gasifier or $8 million on a boiler. So there are 300 or 400 of these gasifiers in Alabama and Georgia, places like that, and they make about 8% of the fuel that goes into those gasifiers comes out as a char. And there are some companies now that are taking that char and post-processing it, doing some refining and selling it into high-value landscape turf-type applications, and it's being distributed through companies like Site One, which is owned by John Deere. So those are two sort of the current sources. There are only one or two companies that are producing large quantities of biochar per year. National Carbon Technologies in the Upper Peninsula is making biochar and renewable carbon, as they call it, from wood waste, and they're primarily supplying renewable non-fossil fuel to the steel industry, but they're also making biochar. And the Kingsford and the other companies that make charcoal that are producing about a million tons of charcoal a year are now looking at biochar for potential products. And I guess just the last comment, one of the reasons that the pyrolysis oils are more advanced in Europe is they have spent a lot more money in Europe over the last 20 years funding bio-oil research and development. So in North America, Ensign Products is probably the leader in bio-oil production. They have commercial oil production. UOP is another producer. And there will be in Chicago TCI Biomass, or it will be virtual this year, a 3-day conference devoted to 1 day to gasification, 1 day to making oil, and the 3rd day to cleaning up the oil for using it. So.
Okay, nice. So we're getting there. We're just a little behind.
Yeah. Thank you for the elaborations, because I know that this is one of the current researches that is ongoing, and then people are putting in much effort to get it replace most of the things that are petroleum in nature. So I'm excited about what you're doing, Tom.
That's a good co-product.
Yep.
Yeah, good. Okay, we've got time for one more question. We've got one in the chat. Can you speak a little bit, Osei, about the storage stability of the oil and shelf life, and how all of that works?
Okay, so I want to be candid with the storage of bio-oil. So bio-oil has water. I think that is one of the main concerns that initially they have had. And the thing is that if you want to store it and then transport it, and you want to remove the water, then at the end of the day, you have the repolymerization of the bio-oil. But then if you want to just transport it, then you are just transporting water. So it's a dilemma. But at the end of the day, like I said, there are technologies that are being looked at to actually make the bio-oil more stable. And this actually calls for other diluents in a process that you can recover. So we have looked about 3 diluents right now, and then how it's impacting the bio-oil. So we can talk about that if anybody is interested. And
okay.
then,
the follow-up to that is what percent is water of the bio-oil?
Yeah, so mostly it's around 19 to 25%. And this is actually contributed by the initial amount of water in your biomass.
Okay.
But
Okay.
it's around that figure.
Any temperature requirements that you have to maintain?
Okay, so if it is not in use, the temperature should be below room temperature. And the reason is that you don't want the bio-oil to start polymerizing at higher temperatures.
Right. Okay.
You just want to keep it as it is. Yeah, but then the viscosity changes completely when you start heating it up. It moves from non-Newtonian to Newtonian fluid within a second. So heat is one of the main things that you could use to get your oil from semi-solids to a complete liquid.
Okay. Okay, good. Thank you for that. We are just about finished with our time. So Osei, thank you so much again. That was a great presentation, really interesting research that you're doing and that you've done. I appreciate the audience with your questions and interaction. there. That made it a great first kickoff of our webcast. So with that, Chris, I'll turn it back over to you if you want to have some final remarks before we sign off here.
Okay, I'll be brief. Thank you to Paige, and thank you to Osei, and thank you to all of you for joining us for this kickoff. We do have our next session scheduled for Wednesday, February 17th. And that will feature Maria Iglesias, who was our 2020 FPS International Conference poster winner, who will be discussing the effects of nanofibrillated cellulose and particle board. So watch your email for further announcements on that session. Also watch your email for a thank you with a link to this recording that will be placed on YouTube for today. One other reminder, we have announced that our international conference for 2021 will be held virtually again. That will begin June 15th and wrap up on the 17th. So a lot of exciting content there. And thank you for joining us today. And that'll conclude today's meeting.
All right, great. Thanks, everybody. Good to see you.
Thank you all. Good to see you. Thanks for coming.
Great job, Osei. Thank you.
Nice job.